Okay, so I'm gonna go ahead and fix the bug that crashes us, just like this. So if we run our game, we crash if our mouse position is not over the space that our grid is. Now that's a problem because, well, it happens because we're trying to print up debugging info for a nil object, which on the very first frame of the game, it doesn't know how to rectify or read from a nil object. So we just have to do a little fix here for that. So if we take a look at the line that we actually crash at, we actually crash like right here on debug 1. We crash right here when we try to index a grid at a mouse position X and Y, because the mouse and X position are nil on that first frame, if they're not hovering over our current grid. So what we can do, we can say if our mouse X grid does not equal nil, there's no tilde on my keyboard because I have a 60% keyboard, so I don't exactly know how to do the tilde. Function shift escape is what it is. So as long as our mouse X grid does not equal nil, then let's go ahead and print our debugging. So we can go ahead and indent all of these, and then give us a proper end here, and then hopefully that'll fix our problem. So it didn't crash there, but let's hover the mouse over here and try to run it. It still crashes. 1759. What's weird is I was experimenting with this during work today, and I thought that that was all I needed to do to fix it. If mouse X grid is not nil, then go ahead and do it. Yeah, it's still crashing. That's so weird. I could have sworn I had fixed that with just that line. So it's still crashing here because I don't know. I thought this fixed it, because we're crashing because the grid at this occupant is in a nil value, but we're only going to access this if it's not equal to nil. But that doesn't fix it. I think the other way we can go about it is to set our debug option to 0. Yeah, maybe we set our debug option to 0. Do we crash there? No? Okay, we're getting that weird. It doesn't crash, but it does highlight the wrong... Oh, it does crash. Okay. My last idea is... in our debug options, we just take out this else, and we only do this if we hold 1 down. So we can say I did Control O, not Shift O. There we go. So I can say if 1 is down, go ahead and debug option. How do you cycle up? Okay, if 1 is down, debug option is 1. And then we would say else if 2 is down, else if 3 is down. So now we don't crash if our mouse is off. Yes, we do. What the heck? 1759, we're crashing. What am I doing? 1759. Yeah, we crash on the same line. Even though our debug option isn't 1. See, that's the thing with the interpreted languages that I'm just not liking at all. Where it's like, we're not even running this line of code, yet this is what's crashing. And it's crashing because it's interpreted, so even though our debug option is not 1, actually, no, we set it to 1 at the very beginning, so if we set this to 0 now. Okay, let's see if we crash. Okay, we're not crashing. Now we're not... See, we're still highlighting those reds when we're over here, which I'm not a big fan of. I know where that's happening. Right here. So if we go to the first cursor, okay. Now we run this, we don't crash, we don't highlight anything unless we're physically over it, which is right. But we're not rendering any debug info unless we hold. Really? Wow, we really just crash anytime we're debugging 1 over here. Okay. It's not worth... This part isn't worth it to fix. because it's not a problem in our main game. It's just a problem because we're trying to debug some stuff. But it's not worth it, man. It's not worth it. I'm gonna revert back. So we've made a couple of changes here, but I want to undo all these changes. And I believe we can do that with, we get our, not our log, but our, we need the commit hash of this most recent commit. And then we can say, get reset with the hard option to reset our working state to be that. And now if we get diff, we don't have any difference, so we should be able to continue where we started the episode. Yeah, so it looks like we got our changes back. Okay, so it's just not worth the headache right now. I really don't. That's been my least favorite thing about Lua, is that it crashes on those instances, regardless of whether or not that line of code is even being called. So I find that pretty obnoxious. It's just the way it's interpreted, I guess. But we don't need it. We'll just have to make sure our mouse is either completely off the screen when we're booting the game, or within the grid, because if it's off the grid but on the screen, it'll crash, just like that. But if it's over the grid, just such a silly problem to have. But like I said, once we turn off the debugging, the print debugging, that won't be a problem anymore. It's just a problem right now because we're trying to print those values. Okay, the other thing I'm doing is I'm rehauling all of our wind state stuff. So instead of doing this, I'm gonna be redoing all this, man. Okay, so let me talk through my reasoning. I decided to do a thing where we check for a middle road first. Like we check for stone control in every column. Then we check for if a middle road even has a horizontal connect. Then we check a first and last connect. And we're running into problems because the middle road can have multiple paths, which means multiple indexes to ask if it's a last connect or first connect, and that just got really confusing. Now what I'm thinking of doing, instead of doing this middle check with a left orthogonal, right orthogonal, I think we're really just gonna do it completely different, and we're gonna start from the left, work our way over to the right. And basically what's going to happen is if we have stack control, we'll just worry about white for now. So like basically now I'm gonna add another boolean to our occupant class. And that boolean's going to be called something like potentialRoad. Now, for our first row, anything that is in our stack control that's not a standing stone would be a potentialRoad. So we would highlight those with like blue or something. And then we need to write a function because all of the subsequent checks are going to be the same, meaning every time we check the next row, we're going to be asking the same things, which is there a orthogonal connect with any of our first rows that are a potential road? So if we have an orthogonal connection, then we're going to change our potential road to true there. But then we need to ask any corresponding orthogonal places. It's such a, like that's the suckiest part of the code, because it's going to be like, oh, depending on the row, depends how many things we need to check and ask for. But once we do that once, then all we have to do is say, we make that function a parameter that we give that function a parameter called stone to check or whatever, like, and if we will pass in the stone, and then it'll turn all the booleans, anything in our stack control that isn't a standing stone, orthogonally, it'll turn that potential road boolean to true, and then any vertical connecting ones it may be connected to, for as long as it goes, it'll also turn that to a potential road true. And then it'll go through the other ones, which in this case, like, let's say if we had this, our new code would then go to say, okay, so this one is a potential road, so let's go orthogonal to see if we've got stack control and not a lay stone or a standing stone, and it would be true, so that would be, this would turn blue. But then again, we would have multiple squares touching it vertically, so those would also be a possible horizontal road for us. And we're ignoring the fact that this setup would be a vertical road. We just have to check. It's easier to write functions for checking individual directions than every direction. It's a lot easier. So we're just going to do horizontal first, then worry about vertical. So ideally, if we do this, if we do what I'm proposing to do correctly, all of these white squares would be highlighted blue, because they're all potentially a road that goes from left to right. And then if this were to have a block here, then only this one would be a potential road, but it would stop there. So the idea is any stone that is potential road highlighted by the time we get to this fifth column would be an actual road. And then this one can only be highlighted if it's connected to this one, which was highlighted, which can only be true if it's connected to another one that's highlighted. So it's like, we just got to build our road all the way across on a column by column basis. So the toughest part about this is going to be to make this function for not only checking the next grid for orthogonal status, but to flip that boolean of potential road and to check its vertical spaces. Because if we accidentally index a space above a row 1, we would crash. And if we index a space above our row 5, we would crash. So that's what's tricky about it. But as long as we cover those cases, we say, okay, if our row that we're checking is a 1, then we don't need to check above us. If it's a 5, we don't need to check below us. But if it's a 2, 3, or 4 on the row, then we need to check the orthogonal status above it, and then everything around it, including, God dang it, it's tough. Yeah, we'll get to it, but that's what we're looking at today. I do not think I'm going to get very far in this. Part of me thinks I just need to reset all of our middle code. Like this middle lateral connect. Part of me thinks we need to get rid of all that. I guess let's redo our nodes. So, where is our nodes? Here. Okay, so our new horizontal win. I wanted to try a shortcut I just learned in Vim. If we highlight in visual mode and then do a lowercase u, it lowercases everything. So we can type comments. We can type comments like this saying, because I don't have caps lock with Vim, it's now escape. I can say that this is the new horizontal. I could type. And then highlight everything. And then say capital U. And highlight it like that. So that's kind of cool. So new horizontal wind detection. So we can say for the first row, first column means that every stone in our control except a standing stone would be equal to a potential road. Okay, so the first thing I'm going to do here is give every occupant a potential road field, initialize it to false, but in our render function for that occupant, instead of highlighting like we want to permanently highlight a blue outline around any potential road. So like regardless of whether our mouse is hovering over it, we just want to render that potential road. So let's see if we can get that done first of all. So we need to go to our occupant class, which is here. So our occupant class is all of our grids, and then each occupant class at each grid has a whole table of 14 members, which holds data like the stone type, the stone control, the stack order, that sort of thing. Actually, the stack order is... No, yeah, I think that is in the members. But anyway, we go to... In our init, we would add a potential road. Set it to false. And then in our occupant render, see how we've got these different things. I'm going to do an occupant render, or if our potential road is true. So if our self potential road is true, then we're going to actually we're going to set our color to blue, and instead of rendering this sort of green color for our move locked, we're going to render a blue color. So we can just go ahead and steal these lines. And then change the color to be blue. So nope. I thought I could change a word with the C command, but that's not how it works. So, okay. So if we're a potential road, then we're going to highlight with blue. So let's go ahead and actually initialize these bad boys to true and see if we're rendering the blue outlines, because that's the first thing we want to test. So let's hope for blue. Now it's only rendering the blue if we're over it. So that blue looks really good. It's only hovering it, it's only rendering it if we're over it. So we need something different, because apparently we're only rendering things if our thing's hovered over it. Where are we doing that? Let me see actually if we start placing these. Then start moving. Yeah, that's not right at all. Where do we render our occupants? I just sworn. Okay. So if it's a move type place, which it starts out of, if the grid under our cursor is a selection highlight and it's not occupied, then go ahead and render, which will render the highlight. So I think we need to do something saying like, okay. So I think we can go ahead and get away with doing something like, you know, we're gonna do all of our old render logic, sure, but then we're gonna go here and say, this is not what I wanted to do. Okay. We're just gonna say if our grid at any of these indexes is true, in the potential road aspect, we're gonna say potential road. Then we're gonna go ahead and render that bad boy. So we'll say grid IJ gets rendered. Does that change anything? There we go. That's what I'm looking for. So we do render. Now we're rendering all of those grids as a potential road. So we've got potential road render working. We just need to populate them correctly now. So if we go back to our occupant class, we can say, okay, this is now insert mode. No. How do I? Okay. We render them false, so we're not going to be. We're still rendering our correct colors here, but if we switch any of those grids to a potential road, it should become blue, because we just tested that. So now we have to worry about actually changing them to blue, actually flipping this potential root boolean, potential road boolean. So if we go over to our play state here, and where are we? Yeah, I'm probably gonna have to take out this orthogonal match flush and orthogonal match. Yeah, I think the first thing we know we want to do is populate. See, the thing is, I don't want to do this every single frame. It's only when we place, only when we update our player in a place move state. Let's find it. Where's the if place? If move type place. Right here. Where do we swap players here? Right here. So instead of doing this horizontal wind stuff, actually we want that still. Instead of doing this determine horizontal wind just yet, we're going to be doing something else. And what we're going to be doing is we need to flush our potential road. Okay, which is a function we haven't written yet, but we need to flush our potential road, and then we need to check any first column roads. So it's like say first column potential road. So if we do those two things, we need to write these functions obviously, but we could go ahead and do that fairly easily. And this is the only special one because actually we could potentially use the same functions for every single column 1, 2, 3, and 4. Because once we use it on all 4 columns, our 5th column would ultimately get populated with a potential road. And if there is a potential road in our 5th column, we know we have a complete road if we program everything else correctly. So maybe we require the running potential road doesn't actually modify something unless you give it the parameter. So we can say that we're going to run it on column 1. Because in a place state, actually, see, this is jacked. I really want to figure out. We're not running our swap player function here. And I think we have a good reason for doing that. I'm just not remembering that at the moment. This won't actually work. We'd have to do... Yeah, I think this is okay to use without a parameter if we cram all of our potential road logic into it. Which I'm not sure we want to do. But... yeah. I think, similar to how we have the movement events in our play state, I think we can do something for our potential road function that says if we're on column 1, it gets a special treatment of anything in our stack control is a potential road. If it's a column 2, then that would only get flipped to true if the if the previous one is orthogonal or it's connected to one that's connected to a first row, or first column. So I guess let's move forward with this because this is looking promising. Flush potential road and then potential road. Is that how you spell potential? It looks so wrong. So we're gonna go give ourselves 2 new functions here. And we'll go ahead and do it at the end of... We'll do it before our determine horizontal win. Now, we'll have those here for reference. Now we need 2... What just happened? I don't know how I did that. But... Dude, what just happened? It's the same thing that just happened. Come on, dude. Okay, all I know is it's potential road and flush potential road. So let's go back up. What is going on here? Oh, I was trying to type F, not in insert mode, which is what was going on there. So we need 2 functions. One function is called flush potential road. And then the other function is called potential road. Now, flush potential road needs to cycle through all grids. What is going on? For I gets 1. Come on, 5. Do. And then. I suck at Vim, dude. I fucking suck at Vim. Okay. We need this to be J. Now we can do we need to just go through all of our grids and set our potential road to false. Okay, that's very simple. We just say I and J. The flush potential road is super easy. It literally just flushes them all to false. We need to do that because every time we update a stack control, it could change our potential road status, so we need to wipe it before we check it again. And you know what? We could probably actually just do this in our potential road function. Our potential road function would flush it right off the bat. That sounds useful, so let's just go ahead and do that. So we can go ahead and delete all that, but let's... And then we can go delete our flush potential road so we know we don't accidentally try to use it. And then, okay, so the first thing we do in our potential road function is flush our values. That's good. Now, we're gonna set our potential road column to 1. I think. And that would probably just be a global variable. Because I'm trying to figure out that flow state of we have to check all of the first columns first, and once those are locked in, we can check the next columns. So road column 1. What if we do a string? Yeah, what if we do a string instead? So what if we say, okay, first thing we do is populate our road, and then we can say if this thing called road column is equal to a string that says not set, then we're going to go ahead and set it to 1. we'll initialize it as not set, and then anytime we anytime we run our potential road function, we'll need to set it to not set. So we could say road column. Holy crap. Holy crap. Road column gets not set. And then if it's not set, we're going to go ahead and set our road column to 1. Is there a difference of just starting at road column of 1? Yeah, we should just start at road column of 1. Yeah. Okay. We can say road column. What would we say if road column is 1? Yeah, we would set and it's not assignment, it is equality. And then we'll go ahead and give us road column would get set to 1 at this point. Okay, we don't crash just yet, so we're allowed to do this without declaring it. It's kind of just declaring it as a global right here. But we run this potential road function. If our road column is 1, we're going to cycle through. We're going to cycle through all of our grids. Right? Cycle through, actually no, we've got our row, so we just need to cycle through our column. Is that right? Cycle through our row, my bad. So we would say, we would know we'd be modifying a grid at our ith row, but in our first column, because this is only the road column 1, we would be going to set potential road equal to true if we indeed have a stack in our control there. Oopsie. Okay. So yeah, we'd go through every row of our first column, and we need to check something. We need to check if our grid at this index of our first column, if that grid's stack control is equal to white, and this is just for white. We need to also nest this into players at some point so we can detect both player wins, but that depends on the player, so and it's not just a stack control, it's that if the stone type is not a lay stone. So we could say if that is white, we would want to first check if the grid at this location ij is going to be a stone control. A stone control that is not equal to function shift escape, not equal to that of a standing stone. So it would have to be a lay stone or capstone, and it'd have to be in our control of white. And if those two are true, then we would go, nope. We would say then that would be a potential road, which should ultimately render it. And we are running this potential road upon a placement. We just need a end here, and then maybe we can test it. 736 we crash, and we crash, what is it, colon 736, right here. Oh, yeah, we don't have a J here, we just have a 1. Look at that. Now we've got a stone control. We've got a potential road for any first column now. So if we put a standing stone there, it wouldn't be a potential road. If we put a white capstone there, it would be. It's looking like that's working. And then if we, since we flush, actually that's not working now. It's not flushing our potential road, which it should be. If the stone controls standing stone, stack controls white. See, its stack control is black. So why is it rendering a potential road? We'd only be a potential road true if our stone stack control is white in that case. Oh, no. Shit, it's almost there. I don't know where the bug is. At least for this first road column. We should be falsifying this potential road. Let me just print up if we're potential road. Let's say right here. We can say think it's as simple as if it's highlighting blue, it's a potential road. If not, it's not. But I don't know that for a fact. So we're going to go ahead and print it out. So we're going to say the grid at our mouse. What, X grid? No, my grid first. And then mouse X grid. That dot, oopsie. That dot, nope. Come on, dude. Insert mode dot. Not right. This. Potential road. Okay. Now we've got potential road. See, so we move a black on top of a potential road. It still says it's a potential road because we only flush it upon a placement. So once we place it, then it'll update it. So we need to do different stuff real quick, which is run our potential road function in other scenarios. If we... Come on, dude. How do you quit a search? I really don't know how to quit a search. Okay, we're gonna snag this potential road function. We're gonna go to anytime we player swap. Yep. We're gonna go to anytime we player swap, and we're gonna right after we player swap, I guess, we can say we're gonna go ahead and run that function anyway. Then find the next player swap and run our function here. And then we're gonna go to our next one. Maybe we just put this in player swap. Okay, we're gonna go to our player swap and just put it in there. Right here, player swap. First thing we're gonna do, actually last thing we're gonna do is run our potential road. Now that should fix our bug. So if we place a stone on top, as soon as we place it, it should unpotential road it, which it does. Otherwise, it's just a potential road. Standing stones do not have potential road, yet capstones do. And then if we move a capstone, for example, out of it, it unpotential roads it, which is correct. Because you can only have a potential road if the white is in there at the moment. So we've got the beginnings of our new potential road algorithm. I think I was onto something thinking about it. And with coding, there's multiple ways of doing everything, so it's not like I was going about it wrong. I'm gonna go ahead and put this line with the other functions up here. Yeah, it's not that I was going about it wrong. It's that there's so many different ways of doing it, and I feel like this way is gonna work because we can reduce the complexity by only having one function to check to enable a potential road on not only any orthogonal connects, but any vertical connects with those said orthogonal connects. That was getting so confusing trying to split up across 3 different functions when we were checking for our middle stuff. So tomorrow we're going to be working on doing that function, given it's basically gonna ask for any given potential stone road, any potential road in a given grid. Yeah, maybe so if just like how we've only done our column 1 for right now of our road column 1 for our potential road, we have to ultimately do something like, not what I wanted. We'd have to do something like, okay, we generated all of our potential roads here, so we would then say road column gets equal to 2 at this point, and then we would do all of those 2 logics. That sort of deal. Because then for road 2, 3, and 4, all those columns need to run the same function of, it needs to check which stones in its previous column are indeed a potential road and only change this column's potential road booleans to true if they are either orthogonal to a previous column's stone control. So I think we do, whatever function we do come up with for this, we would need to give it a road. We would need to give it a column to check previously. So I guess if we would run whatever function we call it something like I don't know what we'd call it. Oh, shoot. Okay. Nope. So yeah, our function for determining the next given potential road columns needs to factor in which column we're currently at. So we can pass in what column, once we've finished all of our road column 1 logic, we would set our road column to 2, and then at the beginning of our road column 2 logic, we would say, okay, run this function that we're going to determine our new potential roads at, but with the parameter of column 2, and that giving in that parameter of 2 will therefore check the previous columns for potential roads, and then we can say, or we can ask if the one beneath us if the one to the left of us is a potential road, then we're going to go ahead and set those orthogonals to a potential road true. And then we just got to, ideally we do it in a function because we need to use this function on columns 2, 3, and 4. And they're all doing the same thing. So ideally we do give it a parameter that we can pass in so that we can modify all 3 columns with the same function depending on which road column we're at. So that'll be the next step, and it won't be that hard, I don't think. The hard part was figuring out that we needed to kind of change this, and putting our road check into a function and a column by column basis is going to help us. It's going to help us. I'm thinking it's going to help us cut down on the potential road problem that we have. But because ideally, if we populate these potential roads, multiple squares could get that blue highlight before it looks like it's, or like multiple different roads could be highlighted so it looks like janky and weird. But we really only need to determine if any road has been made. We don't need to determine what exactly is our road. We just need to say, okay, these are all potential roads, and if it makes it to the end, then it's a road. Yeah, I think it's possible. I think we're going okay at it. So if we go ahead and get diff, we can see we added a couple of nodes. We added a potential road boolean to our occupant class. We're rendering that potential road with a blue outline, if it's true, and then we added our potential road function to our player swap function. And our potential road function starts off with flushing all of our potential roads, and then starting at column 1, turning all of our potential roads to true if it is not a standing stone and it is in our control of white. And then we took out our determine horizontal wind function for now because we don't know how that plays with our new potential road logic. I might want to fix this indenting before we commit. And then we render all of our potential roads only if we have a potential road. Because the way it's set up, the potential road overwrites any given outline. So we want to do that last. And if we don't do this on a potential road basis, it was only highlighting potential roads once our mouse was hovered over it, which is not what we wanted. We've got some new debugging, so I'm going to check the formatting here at line 1015. So if we go to 1015, it just looked like we had some white space or something. Okay, I think that was a fluke, but we can go ahead and commit with a message saying refactoring horizontal wind with refactoring horizontal wind with potential road. Something like that. And push it. Okay. So yeah, tomorrow we're going to work on the actual, our next rows of potential roads. I think this is the way to do it. I'm feeling much better about this way than the other way, even though the other way I was excited about because I thought of how to do it. There was just a more simple way to do it, I think. Yeah. Because it took me 3 episodes of trying to do the old way, and it got more confusing and more confusing. And right now, after doing the first column in 1 day of this, I'm thinking that the next columns, it's like once I figure out the function for tomorrow, we've got all 3 columns working. You know, if I get that function right, then we'll have the first 4 columns of a road detect made, and then all we have to do is do the last connect, and then that'll be very easy. Yeah, very easy. I'm thinking, yeah, I mean, that function's going to be the hardest part of it, but all we have to do is make sure we don't crash indexing a nil value, make sure we're accepting a parameter that checks a specific column before the one we're trying to modify, and then I think we'll be able to do it. So I will catch you guys tomorrow and continue to make progress on this. We're in the home stretch with this game. As soon as we got the wind state detecting working, we can do some more extensive debugging for trying to make it crash. And then we can tidy up some stuff. We can add best 2 of 3 games or whatever, keeping track of points. We can worry about potentially saving and reading from data for a high score table or something. We can polish up the artwork a bit. And then another thing I want to do is to make sure it works full screen on all computer sizes, because right now, if we switch it to full screen, it's not going to work. I can actually show you that real quick. So if we go to our main, and we go to our full screen options, and we say our full screen's actually true, and then we run this, as long as our mouse is in the right position, it won't crash. See this? So this is actually better than I thought, because this is at least putting the stone where the mouse position is. But if we scale this up, to actually be full screen, then the X position and Y position of our mouse are limited to where they are right now. Meaning, if I'm hovering over this spot right here, if my mouse position is right here when it's full screen, it would actually not render the outline at the right grid, because it's based on pixel size, hard coded in. So I want to figure that out too. But yeah, I think we can do that, because right now we're calculating the grid position based on the cursor location of a certain screen size, which is why it works perfectly if we don't resize it. But if we resize it to a virtual screen, we need to calculate those pixels based on the virtual size of the screen, not based on the actual game screen or the window screen. But yeah, we'll get to that when we get to it. We're in the home stretch. I'll just focus on one thing at a time, and we'll get this game made.